So, recording this especially for Wyatt. Wyatt, feel better, bud.
He's not sick.
He's skipping school. Fine. Wyatt, quit being a wuss, I guess.
No, he fell yesterday and his ankle was like,
I'm joking. I have to say that because this goes on the internet. Alright, so when we talk about a piecewise function, does anyone know what a piecewise function is? And yeah, you can look at your notes and kind of probably figure this out.
I know I've heard it. I just learned about this.
So you should have the 14.3 notes, but hold on. So a piecewise function is also known as, and what I want you to put on your notes, because it's also known as, is a step function. Much easier to remember than piecewise is just a step function. So, right off to the beside your piecewise functions, I would write in parentheses step, because that's what else we call them. And we call them step functions because when we think about real situations, who's ever been downtown or anywhere where you have to pay for parking, like in a garage? So when you go to a parking garage, do they tell you how much you're going to pay per minute? No. They tell you how much you're going to pay per hour. So what if I pull into the parking garage at 10 a.m., I stay until like 11:30. Do you think they're only going to charge me for 1 hour? Do you think they'll charge me for an hour and a half? No, they're going to charge me for 2 hours because I was in there for more than 1 hour, which to them is 2 hours. Anything more than 1 hour to them is 2 hours. So a step function is used to describe situations where we cannot have a continuous curve or a continuous line because that doesn't correctly model the situation. If you think about building things and you need a certain amount of feet, well, if one board is 8 feet, then I can't just say I need like a 9th foot, I need 1 point whatever boards. That doesn't make sense. I'd have to buy a whole nother board and then cut it and take whatever I need. But to make the purchase, I would have to buy a whole nother board. So those are the sort of situations where we deal with step functions. So here, if it's $5 just to park, like just to pull in there, and for the first hour. So normally there's a fee that includes the first hour, and that's more than the hourly rate. So then if I see the difference here is 2.5, that's because every hour after the first hour is an increase of $2.50. So does that make sense why this is called a step function? Now, what do these shaded or unshaded points tell me? What, do you like step functions? Oh no, it's boiling in here. Yeah, I'm going to end up a puddle by the end of this. Thank you. I'm going to do some of that in my plane food.
Don't wear a sweater.
It's supposed to snow today. Okay?
It is.
Since there's already a circle underneath it, that means you can't come up.
Ah! Hold up!
An RPG.
Because some of you are talking and not listening. McKenna, say that again.
Oh, okay. So since there's already one circle, there's another one on top, and you can't come to the second one.
There's already a point graph because if I'm looking at 1 hour, how much I pay, if I leave at exactly 1 hour, I'm pulling out of the garage at my like 60th minute, I would pay that $5. But then, if I get to my 60th minute and 5 seconds, I'm now into my second hour, so I bump up to my next step. But that open circle tells me that at exactly 1 hour, I don't pay $7.50, but anything over it, anything just, it's like 1.00000000001, just over 1, is the second hour. And we keep going up like that. Sometimes, depending on the situation, this circle on the bottom would be open and the next circle up would be filled because at 1 hour it bumped me up, or at 1 of whatever we're talking about in that situation. So we might see some graphs like that as we go through here. So a piecewise function is not always a step function, but that's just one of the nicknames. So sometimes we have a range that has one line going one direction, and then we have a gap or a step, and then a range or a linear function going the other direction. So step functions piecewise functions are not always stair-step. They don't always look that simple. So this is another example of a piecewise function. We're essentially combining two functions and we're saying 2x minus 2 is my graph for any values greater than or equal to 2. So that goes here. My other graph, 1/2 x minus 1, is for any values less than 2. So I do not include my 2, but I go anything less than that, so I graph that. Any questions on what a piecewise? It's really just a broken graph function, if you want to remember it like that. Yeah.
I think that would be a good optical illusion. You have like 2 lines of equal length, but then a shorter line instead of one, and a longer line other.
I don't I'm not exactly getting you.
Out that wall.
Oh, yeah. Okay. I kind of know what you mean. Yeah. Yeah, but it's like 20 degrees and it's supposed to start snowing like now. So
Let's bring this
can't
one
go
out.
outside. And there's a forklift out there delivering stuff right now. So I don't know. There's no expected fixed day. Yeah, Wyatt, if you're watching this video, you're missing like the hottest my classroom's ever been.
Ever.
Yeah. Does she have a class right now? I think she does. Check.
I clipped one of the seats. Nope.
No, you can hold it. Be careful. Don't push it too far because the top gets beat up. No.
Just push it.
So.
When'd you say stop?
Right there.
Yeah. Right about where the desks stop.
Can I grab a chair?
So we can have piecewise functions that involve one parabola but not the whole thing, and one linear function. So when we look at this, you really got to look at what's the domain of each function. So my domain of my first function, of my 3x, is values greater than 0. So that gives me my linear function off to the right, and I do not include my point at 0. My parabola section is anything less than or equal to, so I do include the 0 point, and I make my parabola headed up and to the left. Any questions so far?
Are we just graphing for this?
Yeah, and we're going to look at some real life situations about it.
So can I borrow a graphic calculator?
Yeah, but in order to be piecewise, it has to split somewhere. The graph kind of has to be, like, in a way broken. So model this. Try to plot some points and model these functions, paying attention to your domain. I would always start by figuring out what is the y value of my function at the beginning of the domain. So at the beginning of your domain is where x is equal to -1. I'd figure out your y value and start your graph there. So take a second, try this on your own. So we are essentially graphing multiple functions on the same graph, but where each function has a specific range, and the ranges start or stop at the same location. So let's back up here. These are all like straight linear functions, but their ranges start and stop. Then at the same location, start, stop, same location, start, stop. So here, the same basic idea. If my range is coming this way, then my range stops. I step up to my next function, and I continue. When I start at x equal to 2, I plug in a 2, and I say, okay, 2 times 2 is 4, minus 2, my y value there, or my output value, that I have with x, is 2. So that's how I found that. But if I go greater than 2, that takes 3. Well, 3 and 6 minus 2 is 4. So then 3 and 4 bring it back. What we're really doing here is taking the values of the domain, plugging them in to find the output values that will make my range. So start with your top function, plug in -1. So I have the opposite of -1 plus 4. So opposite of -1 is 1, plus 4 is 5. So I start at -1, +5 for my first point for that function. I do this again, moving now greater than -1. So I could use 0. So that's just going to give me 4. I can use +1. So that really turns into -1 plus 4, which gives me 3.
-3. Because it's 3x.
I'm using the top function right now.
Oh,
I'm
sorry.
not on the bottom function because notice I'm going greater than -1.
I heard you say greater than.
So this would keep going because it's a linear function. I could also look at my function and say, wait, my y-intercept is 4, start at 4, my slope is -1, and I could figure out how to get back to the beginning of my domain based off that. So that point is included, and my graph would go that direction. I'm going to look at my second function. Never try to do both of them at the same time. You will just confuse yourself. I start at -1. So -3 times -1, then -1. Well, I get a +3 when I do that multiplication. -1 equals 2. So now I'm at -1, 2. I now shift left because I'm going less than -1. So let's go -2 now. That would give me +6 minus 1. Sorry, 5. So at -2, my value would be 5. And since that's going to keep going that direction, and I know it's linear, I can just draw the line and say it's going to keep doing that. What have I done wrong? Do you see it?
The first circle for the equation should be.
This point, because it was not equal to, has to be open. You cannot use the same point twice. Otherwise, it's not a function, because then it would not pass the vertical line test. What we're saying is that these two equations together are one function. Together they operate to make one function, because this still passes my vertical line test. It does everything it has to. Questions? So when we see the graph and we're asked to make the piecewise function, we then need to analyze what's going on. Where are my breaks? Where are my intervals? So what I see here is I have breaks at -2 and 0, or changes in direction. Now when we go to write this out, we determine which graph or which function or which equation includes. What are we doing? We determine which function or which graph includes that domain point and which one doesn't. So down here, these would not all necessarily have to be these, but what you have to make sure happens is either this line or this line includes this point and the other one can't, right? Because they cannot both include it. So notice my first function is the 2x plus 6. That would be this green line, 2x plus 6, because if I kept going, my intercept would be at 6. It includes the point, so that would have the point. But then my next equation, and notice it has to have a start and stop point.
How are we able to find
How are we able to find
this?
what?
How are you able to find the function?
So I can determine the slope from there, and since I see I can either do the x-intercept and plug that in, or do the just keep going with the slope and determine where would your y-intercept be. Since I see that my slope there's 2, I can determine, oh, if I go 2 more up, I'll go 1 over. 2 more up, I'll go another over. There's my y-axis. It's at 6. So just by what we know about linear functions. So this one does not include the -2. So that would be an open circle. And then down to here, it does include the next point. So that would include, really, come on. No, Jacob. I get it. You might understand this. You might get it. But how disrespectful is it when I'm trying to teach and you're making bow ties? Then my last function here does not include at the 0 point. So again, open circle up to the right. So that's how we determine those 3 graphs. We analyze what is the slope first, then we determine the y-intercept based off that. If they work still. A lot of them are dried up. Cool. Questions? How we determine what the graph is. How we make the function. Try the got it. So again, we have 3 functions. So we would start by writing f of x, because they're going to combine to make one function. I'm going to scoot this over so I have space. I sometimes, to make my life easy, just tell my middle line to include both endpoints. That will make your life a little bit easier. Because then you know that one, both of them have the or equal, and neither of your others will. So my blue line should not be that hard to figure out. That should be the function of just 5. F of x equals 5. Sorry, I forgot my equals sign, so I'm going to put my equals inside of here. They put an equals out front because I forgot to. I'm just going to put it inside. And that would be for the domain. I like to do my middle line first, especially in this situation. It's just easier. So I'm going to say I start at -2. I include that point. I include my next point, and I end at +1. So -2 is less than or equal, since I included the point, x, and x is, I just said that it's included. One of them, either my green graph or my blue graph, has to include it. When I make my blue graph include it, then my green and my red will not, which is easier for me, because I know here, x is going to be greater than and not equal. And then green, x is going to be less than and not equal. And we know they share these points. Green is going to share the -2, and red is going to share the +1. So I already know the domain ranges for all 3. Questions on how we determine those domain ranges? I then need to analyze my green graph. Well, I can see that the slope is a -1. So I know that's -1x. But then there's going to be some y-intercept. If I kept going, my y-intercept would happen at 3. So then I say -1x plus 3, or just -x plus 3 for that domain. And you can also, sometimes instead of putting 4 there, we'll just put like a semicolon. Because we're saying this is the graph where x is less than -2. And then again, now my slope, if I look at this slope, is a +2. It would actually have the same y-intercept point. So now it's 2x plus 3 at x is greater than 1. Questions, comments, concerns? It's just analyzing functions to determine what they are. What's up? You see it now? And technically, my equals should be right in here. But if you forget it, you can put them inside. It's just easier if we just put 1 equals over there. What kind of function? Oh, okay. It's kind of given to you. But when we see the v functions, we know we're talking absolute values. So, an absolute value function really is the combination of 2 functions. Can anyone explain why absolute value is actually 2 functions? Right? Yeah, because it utilizes the negative and positive. So, what we want to do here is look at both the negative and positive situations. So what we're saying is inside of here could be negative or positive. So look at both. My function and actually it's done out for you. When I look there, my split is at the 1. So I know that 1 is going to be greater than or equal and 1's going to be less than. Or you could have 1 be less than equal and the other be, like, you can switch around which graph includes which point. Any questions on how we got to there? You want me to show some of the work? Look at, I gotta erase this. But look at 2 times, take the positive. Exactly what it is. So that would be 2x minus 2 plus 3, which is 2x plus 1. That's how I get one of my functions. And since I can see that's the positive slope, that's going to be the function going to the right. Any issues on how I found that? That one was the easy one to do. I just took the positive situation, exactly what's in the absolute value. The other option, or the other route that we have to take is the negative option. So I do 2 times the opposite of everything in here. So the opposite of x is negative x. The opposite of negative 1 is positive 1. Then I still have to have that plus 3. I now distribute negative 2x plus positive 2 plus 3, which gives me negative 2x plus 5. And that's my second function. Then I just determine who includes the point. These are not rigid. Depending on how you decide to make it, one of them has to include the point. Doesn't matter which. One of them has to have the or equal.
Excuse the interruption. Can I please have Will Frankie to the office, Will?
Any questions on the absolute value situation? Try it on your own. Setting up the math to look at the positive situation and the negative situation, or you can call it the opposite situation if you want. Oh. That should be how you start. The red situation is the opposite. Anyone figure out where, what point they share? So we can look at the shift, right? Is that what you're doing, is analyzing what shift is taking place?
I just tried to graph it.
What do you think it is, Jacob? So look at your parent function, absolute value of x. What has happened to that? Inside of it, where the horizontal shift happens, a +2. So what horizontal shift did that do? A minus, a left 2. The +1 went up 2. So my shared point is going to be at x equal to -2 and y equal to 1. But it doesn't really matter that my y equals 1. What I care is that my shared point is at the x equals -2. Because I can see I had a horizontal shift. Now this -3 out front, your compression factor does not change where your vertex is. So it has no effect. So we know that my domain is broken at -2. When I distribute this, what do we get? What'd you get? -3x minus 5, right? And then we'll determine what we want the domain to be for that. X has to split there. For my negative or my opposite situation, what do I get? 3x plus 7. What do we want to make the domain? Which one is going to point to the left? If we think about the absolute value graph looking like this, which one is going left? The negative slope, right? Because it has to be coming down. So for my blue graph, x is going to have to be less than -2. And now I can make this or equal if I want, but I don't have to. If I don't make it or equal, this one has to be or equal. So then this will be x is greater than or equal to -2. So what we did was we compared the parent function of f of x equaling, sorry, not square root, absolute value of x. And we said, what has happened? Compression factor, horizontal shift, vertical shift. So when I look at where's the vertex of my graph now, the horizontal shift and the vertical shift tell me that. Crap. So that was a horizontal shift to the left 2. This is up 1. So I know my vertex is actually -2, 1. But I don't care about the y value there since I'm only looking at domain. So I know that my domain breaks or my graph changes direction at -2 because that's where the vertex is. Any other questions? Like, please ask, because we're getting deep into the math where if you're missing something small. Yeah, or I was hoping to get the homework out and we could discuss a couple of the problems. Let's keep moving. We can go over homework together tomorrow if we need. We can do some more problems.
Yeah.
So when we graph the step function, those brackets, can anyone guess what those brackets really mean? That's really cool.
Needs clean up.
Is that
There you go. Yes. Happy Pi Day coming up.
I know.
It needs cleaned up.
It's a key printed pie. They also printed my
Oh, yeah, I
exact that I
noticed
keep the
that.
highlighters in. This is pi, but it is, if you start reading, pi starts right here, 3.14, and it's digits of pi all the way around. And in the bottom of it, they printed a pi in the bottom. And then the bottom, if you look through it, it's all hexagons because they all fit together perfectly, so it's the honeycomb design. So check this out at some point. Kavila is like an artist. Yeah, it's the digits of pi going down. Yeah. So, those brackets. Can anybody figure out what those brackets mean based off what the graph shows? Seth?
So like for the first bracket, we'll get two graphs. That would mean like from 0 to 1. Then having the line there is 0. And then for the next bracket, step up and from -2 minus 1.
Yeah. So really what those brackets indicate? Integer. What is the integer value and it rounds down. So you're looking at essentially cut off the partial. So really like truncating at the decimal point. So if I am graphing and my x value is 0.8 and I have to round down, my y value is really 0. If I'm graphing and my x value is 1.7, I chop off the 0.7 and my y value is really 1. So that's why at 1, my y is 1, and anywhere between 1 and 2, my y is 1. But as soon as I hit 2, I step up because I'm at my next integer. Does that make sense? The brackets are telling me integer values. So if I was you, I would highlight, underline, circle, star, something to when x is an integer there. And it is the greatest integer less than or equal to x. Less than or equal to x. Greatest integer less than or equal to. So what's this going to do? Jacob? Yeah, so it's going to do 2 times the integer value of x. So yes, essentially now my steps should each be 2 tall, right? Because if it's 2 times everything, everything expands by 2. So if x was 0, the integer value is 0. 2 times 0, 0. So I start graphing right here, go over, and stop right there. I now say, well, what if now my x is 1? Well, times 2. That's going to give me a value of 2. But this is shaded because it's included all the way up to where x becomes 2, open circle. Then, when x now is 2, it steps up to 4, shaded circle, line across, open point. And we could keep going. We can also go negative, because remember, negative numbers are integers. So go ahead and at least so you have 1 on here, draw the step below, and we could keep going. Just like that. Kind of reminds me of Mario, when you have to like jump up to the different levels. Yeah.
You know his name was Jumpman?
Yeah, originally. Questions on this? Like the actual, yeah. No, well, so Pac-Man I think originally was not a console game. It was just like a game game. Like a,
It was Pac-Man. Yeah, we had to change it because everyone was starting.
so, what if we're given a function? And now we start to name functions starting at f and moving forward down the alphabet. So, f of x is the function shown. G of x is going to be the function x minus 2. So your output values for g of x are the output values of f of x with 2 subtracted away. So if I try to now graph g of x, where do you think would be a good reference point to start? What 0? X equal to 0? 0? Okay, so you see the origin point. So if your output, y, was 0 of the f function, what's my output of the g function? What is it? I think I heard somebody say it. -2, because it just has to shift down 2 from where it was before. So I can shift that down. There's a point. I can shift down my open point circle and say, well, that's going to be another open point. I can really just shift everything down those 2 points. And then connect them. Ooh. So now g of x, actually, with my line going to the right, starts here, filled in, and goes up with a slope of 1? Because it's a different function. And notice I gave it to you, but I like having you guys work a little bit and draw things. So this, if you were only graphing g of x, here's what it would look like. But if you put f of x and g of x on the same graph, it's good to look at them together to see the comparison. All you did was shift down by 2. This gets really funky where they start to say, and this is not what we're saying here, but where they start to say, like 3 times f of x minus 2, or where they do a compression to the function and then shift it. So that gets really goofy, but we're not quite there yet.
Can you do more tomorrow?
So we are out of time. I'll get you guys your homework. So tomorrow, here's what I'll say. We will start with any and all questions from the first 3 homeworks. So we'll start at 14.1 and move forward from there. This homework should not take you very long. It's a whopping 6 questions. So I'm expecting this to be done well by tomorrow because it's 6 questions.
6 questions that take us on this page.
Oh no, I have to grab something.
At least it's not a 6 questions.
All right, have a great day, guys.
Oh,